So in this video, we'll be looking at what these uncertainties that we calculate using the len-est function represent. So I've written here UM, UB, and SY. We'll actually start with SY. This is the standard deviation in Y. And this is a way of measuring, this is essentially a way of looking at the residuals. The residuals meaning the difference between the actual data point and the line that the best fit line. So the definition of this mathematically is that we have a standard deviation where we take the sum of the differences minus the mean difference squared. So this is just a regular standard deviation formula divided by n minus 2 because the degrees of freedom in a linear fit, because we have a slope and intercept, is equal to n minus 2 instead of n minus 1. So this is one of these cases where it's not just n minus 1. For most cases, the degrees of freedom will be n minus 1, but for the fitting of a line, because we have two parameters that we fit, right, we're fitting to this y equals mx plus b, because we fit m and b, each of those subtracts a degree of freedom from our fit. So what this value is it's representing what's the average, roughly, how big are these differences? What's the spread in the deviations in the y values? Now, by definition, d is equal to 0 for a least squares fit. That's sort of the criteria we use to make it the best possible fit. So this equation just ends up not having that second term. Okay, so this is the standard deviation in y. This is a measure of how good the fit is and how far away on average your actual data points are from the best fit line. That's the way I think of it. UM and UB, these are the uncertainties in the slope and intercept. And we won't go through the formulas for these. And the reason these are written as U is because these are standard deviations of the mean. If we continue to get more and more data, these should ideally get smaller. Let me just write that down explicitly. Standard deviations of the mean. So these values are a way for us to estimate the uncertainty in our fitted parameters, in our slope and intercept. Now we'll often use those values, the slope and the intercept, to calculate other things. So these are what are going to go into propagation of error formulas so that we can continue knowing what the uncertainty is in values that we derive from the slope and intercept.